Would like to discuss about the monitors. What exactly monitors are, how monitors are supposed to be so useful for operating systems to maintain synchronization for semaphores. Sorry, synchronization for critical sections. Synchronization for critical sections. So synchronization does means how the processes are supposed to be executed. What is the particular order of execution while it is being taken into consideration? That is called as synchronization. Okay. So as far as a Peterson problem can be worked out for only two processes. So semaphore can be worked out for number of processes. But semaphores, as far as semaphores are concerned, let me open that semaphores here for a while. What we have discussed yesterday, I'd like to open for a while. Then, better to go for this. I think it is the mutex. I think it is semaphore. Yes, this is semaphore. You can see this particular semaphore. Semaphore is trying to trying to apply its own sleep operation. So because of a sleep operation, so obviously your process will be terminated. Okay, temporarily it is being terminated, and then your process will be gets enter into the semaphore list. When the process will be, the semaphore is available for critical section execution. So obviously, whatever the process which is available with the semaphore list, so that is being taken for execution. Meanwhile, there is one a specific and small problem here. What is that problem here is, so the semaphore, while executing this particular semaphore, timing problem will be there. What do you mean by timing problem here? So here it is the semaphore actually, what we have discussed in the previous class. And you please go through your notes, whatever the things I have given in the previous class explanation. You please go through your notes. I am just moving from top to bottom here. Okay. So once it is being moving to sleep, then the process will be temporarily terminated by the operating system, and the semaphore list is being added this particular process. When so the semaphore or other process will be executed the signal operation, obviously, so semaphore will be gets available for a while, and then whatever the first process within the semaphore list, that is going to so wake up and it could be gets executed. So that is what being done here. If the same operation will be done among many number of things or many number of operations processes, the timing problem will be existed. What do you mean by timing problem here? Okay, first problem for so semaphores will be timing problem. It you must write here in the monitors. Why monitors work? Monitors ఎందుకు ఇంట్రడ్యూస్ చేశారు దానికి రీజన్ ఇది. Okay, timing problem. What do you mean by timing problem here in the sense? So the problem when semaphore is being gets executed, then before going to apply sleep, so the process is not really go to where waiting session, and since it is not waiting session, the process will not be executed, so that the CPU cannot pick up another problem from the so ready queue from the CPU scheduling algorithm. So this small gap will be called as timing problem. Timing problem does means when a process is trying to execute. Let me open one more time, then it is very easy to understand. So here this is actually semaphore problem. So ఇక్కడ ఏం చెప్పాం మనం semaphore లో. So when a process is being executed, processes are being executed, if a particular process in mutex process will be taking and executing, another process is trying to enter into its semaphore critical section. obviously the process will be put into wait or busy state. Since it is busy state, CPU cannot pick up other process from the ready queue. Whatever the scheduling algorithm it might be, SJF or primitive SJF, మీరు ఏదైనా ఏ అల్గరిథం అని తీసుకోండి. ఏ అల్గరిథం తీసుకున్నప్పటికి కూడా ఇది వెయిటింగ్ లో ఉంది కాబట్టి ఇది ఫినిష్ అవ్వకుండా నెక్స్ట్ ప్రాబ్లం మనకి కన్సిడర్ చేయటం కుదరదు. సో అయితే సెమాఫోర్ దానికి చిన్న సొల్యూషన్ గా చెప్పుకుంటూ వచ్చాం. బైనరీ సెమాఫోర్ అయితే మ్యూటెక్స్ ఎలా అయితే ఉంటుందో సేమ్ అలాగనే ఎగ్జిక్యూట్ అవుతుందని. దర్ ఇస్ నో డిఫరెన్స్ ఇన్ టర్మ్స్ ఆఫ్ బైనరీ సెమాఫోర్ అండ్ మ్యూటెక్స్, నో డిఫరెన్స్ అట్ ఆల్. Counting semaphore is the solution for previous problem. సో దానికి ఏం చెప్పామంటే ప్రతి రిసోర్స్ కి ఒక పర్టికులర్ కౌంట్ ఇస్తా ఉంటారు. ఆ పర్టికులర్ కౌంట్ బేస్డ్ ఆన్ ది నెంబర్ ఆఫ్ రిసోర్సెస్ అవైలబుల్ ఫర్ దట్ పర్టికులర్ టైప్. సో semaphore will be gives permission to access that particular resource type for critical section. Resources అన్ని అయిపోయిన తర్వాత weight will be modified something like this. Weight will be modified something like this. This is the way of modification. So that is weight of semaphore S and S dot value minus minus. If S value is less than 0, then add this process to S list and goes to sleep. So for execution of these two statements, so these two statements in the sense S equal to value minus minus, and then S will be checking this particular condition, add this process to the semaphore. So list will be taking some time. So this particular time will be called as a timing problem. Okay, this particular time is called as timing problem. So before going to sleep and after execution of the semaphore, what is the time which will be taken? So before going to sleep and after execution of semaphore wait operation, so that particular time will be called as a time problem of enter into so-called semaphore here or sleep here. Okay, wait, temporarily termination or temporarily suspending kind of operation. So to avoid this one, monitor was introduced. మానిటర్ ఎందుకు ఇంట్రడ్యూస్ అయిందంటే ఈ టైమింగ్ ప్రాబ్లమ్స్ కూడా లేకుండా ఉండటం కోసం మానిటర్స్ ని ఇంట్రడ్యూస్ చేశారు. హౌ ద మానిటర్ కెన్ బి? సో యాక్చువల్లీ మానిటర్ ఈస్ ఏ క్లాస్. మానిటర్ ఈస్ ఏ abstract data type. Abstract data type in the sense it is a simple class, something like that. Of course, it is not at all a CLASS. Seems like that as a class here. Let me write the syntax for monitor here. So monitor, the name itself is monitor. Monitor name. Okay, followed by. So whatever the variables they are supposed to share, whatever the variables you are expected to share. So already I have given one particular example as far as the critical section is concerned. That variable is balance updating of your account. The common variable is balance. So similarly here also, whatever the shared variables, those shared variables kind of declarations will be takes place here. So here shared variable declaration, okay, will be taken, followed by conditional. Next one is okay, next one is conditional operations. Conditional. Okay, not actually conditional operations. We must write operations, but here as far as textbooks, it is being considered as XY. Conditions XY. Let me give you what is that XY. Then followed by function. Function P1 of whatever the function which has been done for this particular activity. Okay. Then function P2, whatever the function which has been done for doing some kind of activity. So let me give you what is this. Let me give you what is this. So just for wait for a while, then I'll give you complete information regarding to this particular thing here. I'm copying. That's all. I'm copying. So function 2, and then how many number of functions you are expected to write? You can write your own number of functions here. So function 3, function 4, and so on. So okay, this is function 2. Whatever the same piece of code cannot be there here, but So skeleton will be same as it is, function 2, function 3, and of course you can take any number of functions there. Then followed by finally initialization code. Initialization code. Okay, code of, so it can be taken several number of parameters. Of course, function 1, function 2, function 3 could also be taken several number of parameters here, number of parameters. And whatever the installation code you are supposed to write, yes, you can write and then close this particular monitor. So you can see, I'd like to make somewhat smaller to display everything in one screen. So you can see this is the way the monitor can be seems. Monitor name, shared variable declarations, and conditional, though they are not variables, initial conditions, actually conditions, followed by functions, number of functions, how many number of functions you are expected to have, those many number of functions, then initialization code. Okay, this is the actual monitor. What do you mean by this? What exactly this particular monitor has been depicted you? So here, whatever the particular critical section you are expected to take, so that particular critical section is always trying to access certain number of shared variables. Those variables can be declared here. Those are the variables which are supposed to be declared. Shared variable declaration in the sense, as far as so critical section problem, what are the actual variables or what are the actual data you wanted to share among number of processes? So that is the shared variable declaration. That is the actual shared variable declaration. Then previously, so as far as semaphores or as far as Peterson problem, directly you can access those variables, right? Directly you can access those variables. But as far as monitors are concerned, you are not having a facility to access that particular variable directly. You must access using the monitors. And so there is a separate piece of code which is used to access those variables. So let us consider wanted to get the data of that particular variable, wanted to read that particular data, wanted to read some information from the shared variables. Previously, you just operate just a read of some x. If you turn off your pages towards my first class, you can see this particular statement, read of x. Obviously, if it is x is the variable, shared variable, so that will be read by your process. Delta T naught process 1 read of x, delta T2 process 2 read x, something like that. But right now, this statement is obsoleted. It is not supposed to be done. How you can done here in the sense, whatever the function or whatever the P1, P2, P3, these are the procedures where exactly so use it to read the data from shared variables. Previously, so process P1 colon, so read x will be written by you to read the particular data. But right now, it is not supposed to be write something like this. Process P1 should have one particular statement, something like this. Let me say monitor name is MN, for example. MN, my monitor name is MN. For example, MN. So I'm writing in a shorter names, MN, monitor name, dot, let me say this is actually procedure name. Okay, procedure 1. So P1, okay, of what I am supposed to read here in the sense, I'd like to read a value A, for example, A. Something like this you have to read. There is no read statement. There is no read statement. So read statement will be issued by the process P1, not you. Not you. Okay. Not your process, not you in the sense your process. So this is the way you have to read the data from the particular so monitor here. And so as we said in Peterson problem or in terms of so semaphore, whatever it may be, it must be always to take care of the particular variable here. Before going to take that particular variable, you must take care no other process is being so accessing its critical section. So that is mutual exclusion actually. That is the first property of so shared what is that critical section? Sorry, not shared, critical section. That is the first property of, so critical section will be So protected by taking three different types of characteristics. One is mutual exclusion. Second one is the progress, and third one is bounded weighting. These are the three different types of properties which are used to apply at any point of time. So out of these, mutual exclusion is very, very important. One process is trying to execute its critical section, no other process is in its critical section. So that is mutual exclusion. For doing this particular kind of, for achieving this particular kind of thing, so in Peterson problem, we have taken flag and we have taken turn. These are the two variables where we have taken. And in shared memory, not shared memory, semaphore. In semaphore, so wait and signal. These are the two different types of things we have taken. And in mutex, one is so secure or acquire and release. I think it is acquire. Okay, acquire and release. These are the two operations what we have taken into consideration. But here, how the same thing was implemented here in the monitor. So this locking acquisition or semaphore acquisition, everything is same, but everything will be done by the monitor, not you, not our process directly. Everything will be done by the monitor here. So how it could be done? The conditional statements are supposed to be used. So for that purpose, that is the importance of conditional statements here. Each condition statement, for example, if you are trying to access the value as x, condition x, condition y, there are two different types of shared variables. One is x and second one is y. Before going to access this particular x, what you are supposed to do? So you need to apply signal, wait, weight of x must be taken. Weight of, in terms of semaphore, it must be taken as yes, and it must be implemented something like this. So what is that implementation? The implementation can be seen something like this here. So you are expected to weight will be taken into consideration. You are expected to check the condition here while, don't write anything here, while s is less than or equal to 0, then you can go for waiting state. Otherwise, so s minus. This is the wait operation which is going to be happen. Previously, it was done on semaphore, right? Previously, it was done on semaphore. Now, in monitor, it was done on the variable. That's the difference. Understand? It was done on the variable. So that's the difference. Whomever gets applied so-called variable first, they will be taking care. They will be access that particular variable, and they will be taking care about that particular that process will be taking care of that particular variable. Second person or another persons cannot be taking care anything here. So that's the meaning of this particular monitors x dot condition, x dot wait, and x dot the signal. So here operations will be, first one is x dot wait. This is one operation. Second one is x dot signal. Anybody is wanted to access x variable for its activity, then what exactly it is going to do here in the sense, you must take care about this particular operation first. In our piece of code, you need to write first. You need to take care about x dot wait. So it would be checked that whether x was allocated to anybody or not. If it is being allocated, then you will be put into waiting state. If it is not being allocated, you will be given chance to execute or take the value and do all other operations. Let me write at the end. Let me write the complete piece of code. Just listen here. After completion of execution of this particular shared variable, after taking this one, you will go for critical section. Then you will go for signal. Signal will be always release that particular resource. So X resource will be released by signal. So of course, these two are known to us from the semaphore. Okay, same thing can be gets operated here. That's what. Now, as far as monitors are concerned, how this could be done here? Let me draw one small diagram for you. The diagram will be seen something like this here. Okay, let me take So it would be seem something like this. It would be seem something like this. So here, whatever the particular things are there here, those things are supposed to be taken in the beginning, and whatever the initialization code, those initialization code will be taken here. So this is initialization code, INIT. Let me write INIT. You please write completely initialization code, and this is shared data. Shared data. మీరు బొమ్మ ఎలా డ్రా చేయొచ్చు, టెక్స్ట్ బుక్ లో ఇలా వస్తుంది, ఇలానే రాయాలి, లేకపోతే మార్కులు ఇస్తారు వాళ్ళు. అదొక పెద్ద ప్రాబ్లం ఉంది మనకి ఇక్కడ. షేర్ డేటా. Now, so this particular middle part will be, so whatever the procedures you have written, I mean whatever the functions you have written, function 1, function 2, function 3, which are used to access those shared data. How many number of functions are there? Yes, you can take those many number of functions here. These are the functions. Okay, procedure 1, procedure 2, procedure 3, which are used to share that particular data. For example, your data will be X and your data will be Y, for example. Now, how could you so access this one? For example, process 1, I am writing directly, don't write this particular thing. I'm for explaining process, I am taking this particular explanation. Don't write anything on your book. At delta t naught time, process 1 is trying to access the value of X. I'm not writing anything. నేను ఇక్కడ ఏం రాయట్లేదు, ఊరిని చెప్తున్నాను మీకు అంతే, ఏం జరుగుతుందని చెప్పడం కోసం చెప్తున్నాను. So it is trying to access the value of X. Yes, X is available. I mean, X, the instance of the resource X is available for accessing. Yes, it has been taken. At delta t1 time, so process P2 is trying to access the value of X. X is already allocated to P1, which is not available. So therefore, what exactly done here in the sense, within this one, X might be having its own list here. So P1 is waiting. Sorry, P2 is waiting. Okay, P2 is under waiting state. Followed by any other processes are there, all those processes will be placed into this particular area. Okay, this particular area. So then Y also accessed by some other processes in the sense, and the other process will be waiting state here in the sense. So let me consider, so this is P1 followed by P3, P2 is accessed Y, and the P1, P3 are trying to access that Y, so that the P2 is already taken the access of Y. Therefore, these two processes are under waiting state. Okay, so all these are, for example, one more shared variable will be there for you. One more shared variable. Let me say that is Z. Okay, Z also having such kind of a Q here. So followed by some particular Q, followed by some particular Q, something like that. 10 variables are there, 10 Qs are available with you. 3 variables are there, 3 Qs are available with you. Okay, once anybody, I mean, based on the variable, which particular process is holding that particular data will be issues the signal. Whatever the most recent applied waiting operation, that is going to be released, and that is going to access that particular variable. Okay, that is what being done. That is what being done as far as these queues are concerned. Now, let me talk about some more thing here. So here, all the processes which are being accessed this particular so this particular monitor, this monitor will be, so forms a queue here. First process, so process 1, for example, followed by process 2, for example. All these processes are in a queue, in the specific queue, something like this. Okay, in the specific queue. Don't consider that these are going outside. ఇవి బయటికి వెళ్తున్నాయి అని చెప్పేసి కన్సిడర్ చేయకూడదు. ఇది లింక్ లిస్ట్ ఇక్కడ. సో అందరికి ఆ అనుమానం వస్తుంది. సో ఇక్కడ చివరిలో ఇది రాస్తే లింక్ లిస్ట్ అని అర్థమవుతుంది. It is a linked list which are available in a queue. First process is trying to access the shared data, and if it is available, yes, it can be taken the shared data and do some kind of operations, everything, and then it should be perform the all operations on shared data, and it will, I mean, shared data does means the critical section. After completion of its critical section execution, it will be goes out. It will be goes out. Now, the final thing, initialization section. What do you mean by this particular initialization section here? Initialization section is always trying to initialize the shared variables. Initializes the shared variables. Shared variables. So as like as your constructor of your class. If any class will be taken, class might be having some kind of constructor. Constructor is always trying to initialize the variables, something like that. Now, hope that everything is understood by you. Please unmute yourself and you please talk with me.
Yes, sir.
అర్థమైందా ఏమా మీకు కూడా
Yes, sir. Yes, sir.
Okay. Now, so for example, to access one particular value, let me say x is one particular value and y is another shared value. For example, to access these, normally you people will write getters and setters. Normally, you people will write getters and setters. So this procedure will be considered for getting the data of x and y. This procedure will be considered as a set of the x and y values. Okay, reset of x and y values. Another procedure will be perform some other operation. Other operation in the sense, status of the shared variable. Status in the sense whether it is allocated or not will be taken care by this particular process. Okay, so kabatti ikkada observe cheste, so let me write a piece of code here. First function will be, so let me write a monitor here. Let me open. I'm unable to write each and everything on Paint. Let me open Notepad and can be type everything. Okay, look at this. Oh, time is. So look at this. My monitor is monitor. So MON. Okay, na MON of MON, for example. That is my monitor name. And I'd like to take my shared variables are integer x comma y. Okay, then conditions are, so whatever the condition you could take into consideration here, that condition will be considered something like this: WAIT, weight of x. Okay, let me take it as mutex. Mutex, okay, will be taken as x. Mutex as x. Okay, as x in the sense it is a parameter actually, not directly x. I am talking about a particular parameter. Let me say PERAMETER, parameter. Okay, mutex of a parameter. Okay, however, I'd like to take it as something like this only. Mutex of a parameter. Parameter has been taken. Parameter will be x or parameter will be y, either of these two. So we'll be taking something like this. So if what shall we have to do in mutex? Or you can write a signal, a semaphore also. There is no problem at all. Semaphore is very simple when compared to this one. Semaphore on x. Okay. So weight will be always checks that x yes is less than or equal to 0. Then go for weighting. Not if, it is while. Sorry, as far as while xs is less than or equal to 0, so your process will be put into waiting state. Okay, this process will be goes waiting state. Nothing and wait. Okay, your process will be under waiting state. Then followed by, if it is not so, then what we are supposed to do here in the sense, we are supposed to perform this particular operation. What exactly it is being done. Okay, here as far as monitor is concerned, you please enter one more thing. So what you are supposed to do, so add process, whatever the process which has been operated, that particular process into into whatever the process parameter, that parameters, so waiting list. You need to enter into that particular waiting list and go for wait. Okay. Wait does means it is supposed to be done in terms of what is that? Sleep. In terms of sleep. Okay. If it is not so, then what we are supposed to do? So X, capital X, yes. So minus. Okay, it is under waiting state. And second one is the signal. రెండు ఉండాలి కదా కంపల్సరీ. రెండు ఉండాలి కదా. Semaphore, this is signal. Okay, signal. So what exactly signal will be done here in the sense? So signal will be always done something like this as far as semaphore is concerned. Semaphore will be always doing this particular operation here. So first of all, it is trying to increase the value of x, yes, plus. It will be done. Okay. So then it is going to check that whether the process, any process, other process is waiting. So therefore, AWAKUP, evoke up of, so waiting process in parameters waiting list. It must be done. Remaining everything is not there here. So that is going to be accessed. Okay, it is going to be done. Signal and wait will be monitor in the monitor. Signal and wait will be do something like that. Then, okay, I have taken as integers here. ఇక్కడ integer అని చెప్పి తీసుకున్నాం కాబట్టి integer. So get parameter of parameter. Whatever the parameter he may be access. This is the procedure to access x or y. If parameter is equal to, let me write this particular parameter will be equal to x. Okay. So return x will be returned to the process. Otherwise, return y. Okay. Parameter x అడిగితే x ను పంపించాలి, y అడిగితే y ను పంపించాలి. Okay. Now, suppose setters అనుకుందాం. Setters అంటే వచ్చిన వాల్యూని దాంట్లోకి అసైన్ చేయాలి. సో వచ్చిన వాల్యూని దాంట్లోకి అసైన్ చేయాలి. So for example, so the same thing, no difference at all. So set parameter, if parameter equal to x equal to parameter. If it is x value, then it is parameter. Otherwise, it is so y equal to parameter. Y equal to parameter. Okay, this could be the process to set the parameter. Okay, don't ask me so whether these things will be gets work out or not. I am writing only skeleton. The skeleton will be produced in our examination. It's also accepted. And finally, so initialization is so the monitor mon of, so integer, so x comma okay, integer parameter 1 comma per2. Okay, x equal to per1 and y equal to so per2. Okay, like this it is going to be done. Finally, it could be closed. Like this it is being accessed, and while any process is trying to access this particular parameter here, I mean monitor here in the sense, process 1, I'm talking about process 1. So look at this. So within this particular process, somewhere else it should be seen something like this. While ఇది మనకి ఎప్పుడు అలవాటైంది TRUE while true. First of all, what you are supposed to do, you need to initialize the monitor here. Okay, the initialization section will be there in the beginning. Okay, then let me say my monitor name is M. MON as M. M is my monitor name. Now what you are supposed to do here in the sense M dot capital M, sorry, capital M dot. So what is that? Signal, capital M dot. So what is that? Wait is my process here. Wait is my process here of, so X. This is the first statement. Then my critical section. Whatever the critical section I want to do on X. Okay. Then M dot, what is that? Signal, I think. Signal. Okay, signal of X. Then what critical section should have? Critical section might be having, so M dot set parameter, sorry, get parameter of X. అంటే ఇది క్రిటికల్ సెక్షన్ లో నువ్వు ఎగ్జిక్యూట్ చేయాల్సింది, దీంట్లో ఉండకూడదు, నేను మామూలుగా రాస్తున్నాను. Put parameter, put a set parameter of X. Like this it is going to be happened. ఇలా ఉండాలి క్రిటికల్ సెక్షన్ లో మీరు రాయాల్సినవి. సో పారామీటర్ తీసుకొని యూ కెన్ డూ యువర్ ఓన్ ఆపరేషన్ హియర్ ఆన్ X. యూ కెన్ డూ సమ్ కైండ్ ఆఫ్ ఆపరేషన్, వాట్ ఎవర్ ది ఆపరేషన్ ఆన్ X you can do here in our program, and then you have to supply the same updated value to the set parameter. On the monitor you have to take the set parameter. Okay, then signal. Okay, that's what the process will be performs this way. The process